Xin chào, tôi là Lan từ LangGraph. Tôi đã nói về một bài báo gần đây có tên là Storm. Bài báo này kết hợp 3 chủ đề thú vị. Đầu tiên, nó tập trung vào sự hỗ trợ được trung gian bởi AI. Chúng ta đã thấy nhiều ví dụ về điều này trong những tháng gần đây. Ví dụ, có nhiều công trình đáng kể về hỗ trợ viết mã, với GPT-style Engineer là một ví dụ phổ biến. Cũng có rất nhiều công trình về hỗ trợ nghiên cứu web, chẳng hạn như GPT-style Researcher và các công cụ khác. Vì vậy, chủ đề đầu tiên là ý tưởng về sự hỗ trợ cho các tác vụ cụ thể. Chúng có mục tiêu cụ thể hơn so với việc tạo mã hoặc nghiên cứu web thông thường. Chủ đề thứ hai liên quan đến việc sử dụng Retrieval Augmented Generation, RAG, để hỗ trợ quá trình tạo. Có một bài đánh giá tuyệt vời ở định dạng tweet và bài báo về Retrieval Augmented Generation cho nội dung. Nó khám phá nhiều ứng dụng của RAG, bao gồm tạo mã, tạo hình ảnh và xử lý âm thanh, và vân vân. Đây là một chủ đề thú vị, nơi RAG trở thành trọng tâm của một số quy trình tạo sinh, có thể bao gồm mã, nghiên cứu hoặc các ứng dụng khác. Tiếp theo là chủ đề về các vai diễn, để giải quyết các vấn đề cụ thể hoặc thực hiện mô phỏng. AI có thể nhận các vai diễn khác nhau, tham gia vào các cuộc tranh luận và động não ý tưởng. Một ví dụ hấp dẫn là bài báo về các tác nhân sinh tạo từ Stanford. Đây là một trong những công trình tiên phong sử dụng các tác nhân sinh tạo trong mô phỏng, nhằm tái hiện hành vi của con người, được trình bày dưới dạng trò chơi hấp dẫn. Ba khái niệm này hội tụ trong công trình gần đây hơn, Storm, cũng của Stanford. Bài báo có tiêu đề. Về cơ bản, STOPR là viết tắt của Synthesis of Topic Outline Through Retrieval and Multi-Perspective Question Answer. Nghe thì có vẻ phức tạp, nhưng ý tưởng cốt lõi là kết hợp ba khái niệm này để tạo ra các bài viết Wikipedia. Đó là điểm mấu chốt. Đây là một minh họa đơn giản hóa về quy trình. Chúng ta cũng sẽ đi qua mã nguồn và xây dựng cái này từ đầu. Hãy cùng xem nào. Ở đây, bạn có thể thấy tổng quan. Đây là những gì đang diễn ra. Bạn bắt đầu với một chủ đề, sau đó phân nhánh thành hai quy trình chính. Chúng ta hãy xem nhánh dưới trước. Một LLM lấy chủ đề ban đầu đó và mở rộng nó thành một vài chủ đề liên quan. Đối với mỗi chủ đề liên quan, nó truy xuất các bài viết Wikipedia có liên quan. Các bài viết này đóng vai trò như các mẫu hoặc ví dụ, có thể được sử dụng làm cơ sở để viết về các chủ đề tương tự. Bây giờ, các bài viết và câu hỏi này được dùng để tạo ra các nhân vật biên tập viên wiki. Đây về cơ bản là các nhân vật AI được thiết kế để đóng vai trò biên tập viên, đặt câu hỏi về nhiều chủ đề khác nhau. Chúng ta cũng sẽ tích hợp các module chuyên gia. Các chuyên gia, am hiểu lĩnh vực tương ứng của họ, sẽ sử dụng các công cụ truy xuất web để thu thập thông tin. Cho việc này, chúng ta sẽ sử dụng Tableau, mặc dù các công cụ khác cũng có thể dùng để trả lời câu hỏi. Về cơ bản, chúng ta bắt đầu với một chủ đề ban đầu, chia nhỏ nó thành các chủ đề con liên quan, và sau đó truy xuất các bài viết Wikipedia phù hợp. Các bài viết này sau đó sẽ được dùng để khởi tạo các biên tập viên. Vậy, đó là giai đoạn 1, xây dựng các biên tập viên. Một cách riêng biệt, chúng ta sẽ xây dựng một module chuyên gia có khả năng trả lời câu hỏi. Cuối cùng, các biên tập viên và module chuyên gia sẽ tham gia vào một cuộc tranh luận. Chúng ta có thể triển khai một quy trình hỏi đáp, hoặc chúng ta có thể dùng LangGraph cho việc đó. Điều này liên quan đến một vòng lặp tranh luận, khá thú vị. Vòng lặp sẽ tích lũy cuộc thảo luận về các chủ đề liên quan. Khi chúng ta có cuộc thảo luận đó, như bạn có thể thấy ở đây, chúng ta sẽ sử dụng nó theo hai cách. Đầu tiên, chúng ta sẽ dùng nó để tinh chỉnh dàn ý cho bài viết cuối cùng của chúng ta. Điều này giống như một nhánh song song trong quy trình. Chúng ta sẽ lấy chủ đề và xây dựng một dàn ý chung. Sau đó, chúng ta tinh chỉnh dàn ý đó dựa trên cuộc thảo luận. Thứ hai, chúng ta sẽ lấy cuộc thảo luận và đưa nó vào một vector store để dễ dàng truy xuất. Chúng ta cũng sẽ có một người viết phần chịu trách nhiệm chi tiết hóa từng phần trong dàn ý đã tinh chỉnh. Cuối cùng, chúng ta sẽ có một trình định dạng wiki để xây dựng bài viết cuối cùng của chúng ta. Đó là luồng tổng thể. Chúng ta sẽ khám phá một chủ đề và các khái niệm liên quan, xây dựng một trình soạn thảo wiki và một nhân vật chuyên gia để tạo điều kiện cho cuộc thảo luận. Cuộc thảo luận này sẽ được ghi lại trong một kho vector để truy xuất. Hơn nữa, chúng ta sẽ sử dụng cuộc thảo luận này để tinh chỉnh dàn ý của một bài viết wiki. Sau đó, chúng ta sẽ đi sâu vào việc phát triển chi tiết hơn bài viết bằng cách sử dụng kho vector, nơi chứa các cuộc thảo luận chi tiết cho từng phần, và định dạng nó dưới dạng wiki. Về cơ bản, đó là toàn bộ quy trình. Chúng ta sẽ tham chiếu lại nó khi tiến hành vì sẽ có một số đoạn mã liên quan. Vì vậy, chúng ta sẽ điều hướng giữa dàn ý và việc triển khai. Nhưng trước tiên, hãy bắt đầu với khía cạnh mã hóa. Tôi có một sổ ghi chú trống ở đây với một vài lệnh cài đặt tiếp ban đầu. Ban đầu, tôi sẽ xác định chủ đề chúng ta sẽ nghiên cứu. Gần đây, tôi đã tập trung vào các LLM có ngữ cảnh dài. Video trước của chúng ta cũng đã đề cập đến điều này. Vì vậy hãy lấy nó làm chủ đề ví dụ, tác động của. Các chủ đề liên quan được xác định bao gồm tác động của các endpoint không điều kiện và ref. Tuy đây không phải là những chủ đề liên quan hữu ích nhất, nhưng chúng sẽ phục vụ mục đích của chúng ta.
So all this is doing is we're defining our two LLMs. That's fine. We're going to have a prompt here that you're writing a Wikipedia article.
Chúng ta có thể kết hợp nhiều bước ở đây.
And okay, so basically the related subjects we find are, impact of non-conventional lens.
Hãy bắt đầu bằng cách xem xét mã nguồn.
Not the most helpful set of related topics here, but it'll work. So then what we're going to do.
Trong luồng này, quá trình liên quan đến việc tạo các chủ đề liên quan.
So, we'll just go ahead and kick this off and I'll kind of walk through the code here. So, again, where we are in the flow is this related topic generation, retrieval wiki pages, and creation of our editors. And we can kind of see here's the editors that we created. Now, how did that work? If we just look at the code, we can see this was the chain that we defined above to expand the topics. So into these related subjects. So it did that first. And then it retrieved wiki articles relevant to that, to each of our subjects. That's fine. So it retrieved them. It does a little bit of formatting. And then it generates these perspectives, or different personas, so to speak, for our editors. And we can actually go back and look at that chain. Here is our gen perspectives chain. And here's our prompt. You need to select a diverse and distinct set of Wikipedia editors, work together, and that's basically what you do. I will make the interesting note here that we're using structured outputs quite a bit in this code, and of course you should look at the notebook that's going to be linked to this video to kind of walk through it all in detail. But this is very useful and important here and more generally. So in particular, what we're doing here is, with structured outputs being bound to our LLM, and it's using this perspectives thing. So what is that? Well, that's a pydantic object that we define right here that basically defines what an editor is. And so basically this class editor defines a bunch of attributes that every editor has, which we then capture in this perspectives pydantic object. And the key point is this. Every one of our editors has a very nicely formatted kind of description, so to speak. So here's our list of editors. Here's each one, the affiliation, the name, Dr. Researcher, the roles of researcher. The researcher will focus on analyzing the impact of, context, long context RAG. And anyway, you kind of build a set of editors that are going to be responsible for different questions, basically, in this discussion we're going to create shortly. So that's kind of cool. Now what we're going to do is we're going to give these editors the ability to ask questions. So that's kind of the next thing we want to do. Let's copy this over and we'll kind of kick this off. And so that already ran. It's very quick. So all that's happening here is we defined this generate question chain. And really all that's happening here is we basically are defining the editor that we want to work with. And then we have this gen question prompt, which is right here. So you're an experienced Wikipedia writer. You want to ask a question. When you have no more questions, say, thanks so much for your help to end the conversation. So that's we'll see this is used later to kind of terminate the discussion. And again, we have a bunch of, we define a number of objects here that will help mediate the discussion, as we're going to see shortly. And again, there's like kind of a lot of code here. So I encourage you to actually look at the notebook. This just kind of gives you in broad strokes the main pieces that are involved. So basically what happened here is we invoked this generate question chain with our editor, and this messages, you'll see, is basically a question. So you said you're writing an article on the impact of million plus tokens on RAG. And what we say, basically, that's how we kind of initiate this question answer chain with like kind of an introduction. And this was kind of the answer. This is the output. So you give the editor persona kind of an input like prompt, and then it performs this question generation. You can see the question that's generated is, yes, that's correct, responding to, so you were writing an article about this main topic, right? And yes, that's correct. I'm focusing on analyzing the impact of million plus token context windows on RAG. This includes looking into how these language models improve generation, blah, blah, blah. Is there any specific you would like to know about this topic? So, that's how you set up question generation that the editor will use in this discussion with the expert. Okay, so now what we can do is, here we're setting up the expert. So actually, I'm going to delineate this. So we'll call this the expert. Okay, and then this is the editor. Here's the editor. Cool. Great. Now here's the expert. Now, the first thing that the expert's going to do, so the expert is going to be more like a search tool. So the expert's going to do is it's going to take the input question that the editor provided, and it's going to break that out into a few sub-questions, try to answer each of the sub-questions. So this is kind of the first part, where it took that input question about the impact of million plus token on RAG, and it fans it down to a few kind of related sub-questions. This is kind of just helps in like defining a better answer. So again, we're inside the expert. The first part of the expert is like taking what the editor asks and trying to fan it out into a set of sub-questions. So this is then where we're going to define the full expert answer chain. So this is basically a decent amount of code. Again, I encourage you to actually look at the notebook to kind of grok all the details that are going on here. But this is the high-level idea. We have this gen answer function, and you can see it already ran, which is pretty nice, where we're taking in like the current state of the interview. We'll see why that's relevant in a bit. And basically the name is subject matter expert, as like the kind of the default name. And what's happening is you're basically setting the role to be the expert. You're generating those sub-questions that we just showed above. And now what you're doing is you're calling a search engine. You're using a search tool just to search for things related to the topic that you were asked, or actually to each sub-question that you generated. You perform a search, and don't worry about too much about these details. You're basically getting the cited URLs, and you're also calling this generate answers chain, which is going to that's going to be, let's see where that is. Yep, right here. So you have gen answer prompt. You're an expert. You can use information effectively. You're chatting Wikipedia writers who want to write a Wikipedia page, and that's really it. And you're basically going to pass in information from search to provide this final answer. And here we go. You can see this final generation here. So there's a generation. Here's the cited URLs. And we kind of format the final message. You get our answer, and we can look at it here. So million plus token windows have significant impact on RAG. Large windows extended context will allow for complex prompt execution. So, and basically the point is this. You take the input question from the editor, you fat it out to some sub-questions. For each sub-question, you kick off like a web search. You get a search result and a URL back. You kind of consolidate that into a final answer with all your citations. That's really all that's going on here. So if we zoom all the way back up to like the kind of overall flow here, we have taken our topic, broken out to subtopics, defined a bunch of editor personas, defined our expert personas, given the editors the ability to ask questions, given the experts the ability to answer questions using web search. That's really it. So we set all that up. Now what's pretty cool is we have defined a few functions to enable all this. Now what we can do is we can set up that interview graph. You can see the code here, and boom, here we go. And actually, this is pretty nice. We can actually render the graph visually so we can look at it. So it's the start of the graph. We'll ask a question. We'll answer it. We'll route back to ask another question, unless we had a stopping condition. Or remember, in the editor prompt, there was basically this specification, say thank you for your help if you're done, if you're satisfied. And that's what we basically do in this answer question route messages thing. You can see right here. So basically, if the question ends with "thank you so much for your help," you end, or if basically the max number of turns you define as 5, so you go 5 turns, or the editor is satisfied and you're done. So that's really it. And we can go ahead and actually go test that. So let's just try to run that. So this will take a little bit to run, but you can see this is just the discussion, like basically following, and we're printing it out at every stage. So you can see kind of the entry point here. So the entry point is, so you said you were writing an article on our main topic, which was long context, long context model impact on RAG. And you can see this actually just followed the discussion, which is pretty cool. Yes, that's correct. I'm interested in understanding, what's going on with that topic. So, this is what the expert says. The use of $1 million tokens has a major impact. Thank you for such insight. So actions is kind of neat. Using a graph to mediate a discussion between editors that we've created and experts on this topic. And so you bounce that back and forth. And now this is captured in this final graph state. So you can see we've just mediated this graph. It's running, not too long, maybe like a minute or so. Now what we're going to do here is we're just going to go ahead and store that in a retriever. And there we go. So we can actually just run retrieve invoke, give it a question, and we can retrieve information from this conversation we've had. So let's just pull back and think about what we've done here. So I think it's pretty cool, actually, even though I get it's a lot of code. So you have to look at the notebook to really grok this, but at least I want to walk through the high-level ideas. Again, we've taken a topic, we've broken it up to subtopics, we've used those to build a number of editors. We've also defined an expert. We've let the editors and expert have basically a discussion mediated by web search to build an understanding of this question, and we've put that in a vector store. That's all we've done. But it's pretty cool because we've used LangGraph to kind of mediate this interaction between simulated editors and simulated experts, which are effectively just a search tool, right? So that's kind of nice. And we've done that, and we've built out from that a vector store that we can retrieve things from accordingly. So that's really it. Now to some of the kind of a little bit more straightforward pieces here, because I know that's kind of a mouthful to digest. We're going to now take our input topic again. Remember, this example topic's our input. We're going to build an outline of our blog, which we talked about kind of up here at the top. Now we're entering the top branch here. We're generating a high-level outline of our topic. So we should have that done. So this is pretty cool. We have a high-level outline now. That walks through an introduction, RAG framework, and so forth. And now, following the flow we outlined, what we're going to do is refine that outline a little bit based on the discussion we've had. And so this is going to run. You can see we set up prompts here. Your Wikipedia writing, you've gathered information from experts and search engines. Now you're refining your outline, and that's really it. So this is kind of a refinement stage. Here's the old outline. You're refining it based on the discussion with the expert. And so, okay, cool. There we have it. So this is a slightly refined outline. Again, initially the outline did not use our conversation at all. This was just the LLM reasoning about our topic, defining a sane outline. Now we refined it a little bit based upon the discussion that we've had. So that's pretty neat. And now what we're going to do is actually build a more refined outline, or actually what we're going to do is flesh out each section in our outline in detail. So if you go back to the top here, what's happening is we've had our discussion. We've had our discussion. We've also saved it in a vector store. We've built our outline. We've refined our outline. And now where we are is we're in the section writer stage. So the section writer is basically going through that outline and actually writing the sections accordingly, referencing our vector stores contains the expert editor discussion. So that's really what's happening now. We're fleshing out the outline in detail based upon the discussion between the experts. Here we go. This is pretty cool. So you can see it's streaming. Pretty nice. It's actually writing it out for us right now. Look at that. Not bad. Yeah, it's kind of fun to see that. And see, it's still going. Cool. It's writing out the references for us. So there we go. We're actually getting really close here. Now what I'm actually going to do is I'm just going to capture all these in like one final graph. So here we go. Cool. Look at this. So this basically is our whole workflow. This is just wrapping what we've already done. So we can like run it all end to end, which is pretty cool. And what we're going to call now is let's go ahead and try to run all of that. Boom. So this is going to maybe take a little bit. And we're going to ask a new topic now. We're going to say topic, Groq, NVIDIA, Llama CVP, and the future of inference. So that's pretty cool. We're starting from scratch, new topic. You can see we kicked off that conversation. In fact, let me pull up next to this while this is running our diagram so we can kind of like follow along. So here's our diagram right here. Nice. And we can see that where we are currently in the flow is that we're in the wiki editor persona, an expert persona discussion about inference. And we can see that we've kind of started it with the overall topic, Groq, NVIDIA, Llama CVP, and the future of inference. And then we've initiated the research. So there was our overall topic. We've defined an outline. And so right now it's probably in the discussion stage, effectively here, which is like kind of the most time consuming stage of the overall flow. We actually can go over to LangSmith and we can see what's actually running at any point in time. So I just open up LangSmith. This is pretty neat. So I can look at all these pending things in LangSmith, tell me what's actually running right now. Okay, this is kind of nice. We can see kind of like where we are in the flow. Here's the various subject matter experts, for example. Here was a kind of our introductory question. This is actually showing the discussion that's ongoing between our subject matter experts and our, this is pretty cool, our various editors and the experts. So this is actually like what's happening under the hood as this is running right now. We can investigate some of the other kind of ongoing things. Right, I see. So this is what's happening right now. Basically, a number of these discussions have been kicked off between different subject matter experts and different editors. So this is pretty neat. Let's actually look at this in detail because this is kind of fun. So here's the subject matter expert. So you said you were writing an article on Groq, NVIDIA, Llama CVP, and the future of LLM inference. So this is our editor. Yes, that's correct. I see you're interested in machine learning and tools optimization. Can you provide me with more information about the specific contributions of Groq and NVIDIA in the field of machine learning? So look at all these references it pulls up. This is pretty good. So it gives like kind of a nice overview here. Groq, a company focused on creating chips for running AI models efficiently, developed a LLM, the LPU, which is accurate. So this seems to be sane as of right now. This seems correct. They've demonstrated superior performance in LLM inference compared to GPUs. So this all looks pretty sane to me. NVIDIA, obviously, it talks about NVIDIA and NVIDIA's role in inference, provides lots of citations, which is pretty nice. So then this goes back to our editor, asks a follow-up question, subject matter expert kind of answers in some detail, a few more references, this great information. And I believe that is really cool. And then we get an output. So this is the output of that discussion. Pretty cool. And we can see we kicked off a bunch of discussions along these lines. And it looks like, look at this. Here's our article. It's all written. So this is kind of like some of the discussions that were logged. And look at this. This is pretty neat. Here's our article. Large language model inference advances in future directions. Here's an intro. Look at this. Not bad. It's pretty detailed. Talks about Groq, talks about LPUs, benchmarking, impacting AI models, and NVIDIA's contributions, hardware innovations, frameworks, on the CBP. Not terrible. The final set of references. So, that took maybe 5 minutes. It felt a little bit long. I understand here sitting in as the video was going. But, this actually compiled a fair amount of information. It structured it pretty nicely. It gave us references. It's pretty cool. And again, we can use likes to look under the hood and see kind of what's going on in all these discussions. This is, you can really audit, like we did previously, the discussions between the editor and the expert. And, again, I maybe just want to zoom back up and show you the overall flow. What we did here is we showed how to use a few different ideas, retrieval, personas, to basically perform wiki writing from a given topic. And we took the topic, we built a general outline. In parallel with that, we took the topic, we built some personas, we built experts, we had them discuss. We then captured the discussion. We use that to refine our outline. We basically capture that in a vector store. We use that to write the individual sections of our outline. We then produce a final wiki formatted correctly. And boom, there we go. On a topic of interest to us from scratch. Took about 5 minutes on Groq, NVIDIA, LMCP, and the future of inference. So anyway, I understand there's a lot of code. You're not going to be able to grok all the code just from listening to me. You should absolutely look at our notebook because it's pretty cool. And definitely recommend playing with this. I think the ability to use these ideas, different personas, and assistance, whether it be for code or wiki generation here, are really powerful. And these things will probably all be highly refined and used very frequently in our workflows in coming months and years. So thanks a lot.